there's part of the quadratic formula which goes b squared minus 4ac, right? Now, this in particular can be used to work out how many intersections a quadratic graph can have with the x-axis. Now, your quadratic will be in the form ax squared plus bx plus c, right? And you're going to have values for a, b, and c. When you plug those in to b squared minus 4ac, which is your discriminant, if that is a value greater than 0, that means you have two distinct roots. That means in your quadratic graph, you're going to have 2 points where it crosses the x-axis. That's what it means by 2 distinct roots. If your b squared minus 4ac is equal to 0, that means you have one real root. So it just touches your x-axis at one point, like that. If your discriminant is less than 0, that means you have no roots. So it doesn't intersect the x-axis at any point. That's the whole use and that's the function of the discriminant. It's only to figure out how many roots you have. So let's take this example. Find the values of k for which x squared plus 4x plus k equals 0 has 2 distinct roots. 2 distinct roots means your b squared minus 4ac is going to be greater than 0, equal to 0, or less than 0. Which of those 3? Greater than 0. So, what's your a equal to? What's your b equal to? And what's your c equal to? You're going to look at the numbers in front of your x squared and your x, and then you're going to look at your last value. So your a is 1, b is 4, c is k. And all you're going to do is sub it into your discriminant. So 4 squared minus 4 times 1 times k greater than 0. 16 minus 4k is greater than 0. 16 is greater than 4k. That means k is less than 4, or 4 is greater than k. So the values for which that function has 2 distinct roots is any value of k which is less than 4. That's it. That's how you use your discriminant. Hopefully that made sense. And I've put up 3 questions on the board. I want you to pause the video and give those 3 a go for me, please. Okay, first one. Find the values of k for which x squared plus 6x plus k equals 0 has 2 real solutions. So, our discriminant, b squared minus 4ac, is greater than 0. A equals 1, b equals 6, c equals k. You plug that in, 6 squared minus 4 times 1 times k greater than 0. 36 minus 4k is greater than 0. 36 greater than 4k. So k is less than 9, or 9 is greater than k. Cool? Question 3. Find the values of t for which 2x squared minus 3x plus t equals 0 has exactly one solution, which means b squared minus 4ac is equal to 0. Do the same thing again. A is 2, b is minus 3, c is t. Sub that in. Minus 3 all squared minus 4 times 2 times t equals 0. 9 minus 8t is equal to 0. T equals 9 over 8. Cool? Alright. Question 7. Find the discriminant of hx in terms of k. They haven't told you 2 roots, 1 root, no roots. So you don't care whether it's greater than, equal, or less than 0. You just want to express the discriminant b squared minus 4ac. A is 2, b is k plus 4, c is k. Substitute those in. So k plus 4 all squared minus 4 times 2 times k. So k squared plus 8k plus 16 minus 8k, k squared plus 16. 8k minus 8k is 0. So k squared plus 16, that is your discriminant. Part B is a little confusing. Hence or otherwise, prove that hx has 2 distinct real roots for all values of k. So you're essentially trying to prove b squared minus 4ac is greater than 0. So you're essentially trying to prove that k squared plus 16 is always greater than 0. Let's split it up. K squared, regardless of what value of k you have, will always be greater than or equal to 0. Because if k equals 0, then k squared equals 0, right? If k equals 1, k squared is equal to 1. If k equals minus 1, k squared is still equal to 1. Regardless of what number I have, whether it's positive or negative, my value of k squared will always be positive. And if it's 0, then it's going to be 0. Cool. So if k squared is always greater than or equal to 0, k squared plus 16 will always be greater than 0. Therefore, the discriminant is greater than 0, which means it has 2 distinct roots. That's it. That's the discriminant.